When we think about the solar system, we usually picture it as a bunch of separate things, right? There's a star, some planets, a few asteroids, just a collection of objects. But what if that's the wrong way to look at it entirely? What if our cosmic home is less like a big machine and a lot more like a single living thing?
So, this whole idea is built around a pretty wild concept that our solar system is what you might call a unified manifold. It sounds complicated, but just think of it as a single, self contained system where every single part is deeply connected to everything else, constantly looping back on itself in these really surprising and intricate ways.
And to really get our heads around this, we're going to use this amazing ancient symbol, the Ouroboros. You've probably seen it, the serpent eating its own tail. It's the perfect metaphor for a cyclical, self-sustaining system where the end is always the beginning. And today, we're going to use that idea as a lens to really dissect the anatomy of our solar system. Okay, so first things first. Every living thing needs a skin, right? A boundary that separates in here from out there. Well, for our solar system, that skin is the heliosphere, this enormous magnetic bubble that the sun blows out into space, shielding all of us from the rest of the galaxy. And just like our skin, it's not just one simple layer. First, the solar wind hits something called the termination shock, where it slows down like crazy. Then it churns through this turbulent region called the heliosheath. And finally, it reaches the heliopause. That's the absolute edge, the final frontier where our system pushes back against the galaxy. In fact, our very own Voyager probes, they've actually crossed it. They've touched the interstellar void. But here's the really cool part. This skin isn't totally sealed off. It actually works more like a cell membrane. It kind of breathes. It pulls in these neutral atoms from deep space, it processes them right at the boundary, and then it exhales them back into the system as super high energy particles. It's this constant, almost metabolic exchange with the galaxy around it. Okay, so we've looked at the skin. Now let's dive right into the heart of the system, the sun. Because right there, at our core, we find this massive paradox, a mystery that goes all the way back to the day the planets were born. So, check this out. It's a real head-scratcher. If the sun and all the planets were born from the exact same spinning cloud of gas and dust, you would naturally think that the thing with basically all the mass, the sun, would also have all the spin, right? But it doesn't. Not even close. I mean, when you look at the numbers, it's just wild. The sun has almost all the stuff, 99.8% of the mass, but the planets, especially Jupiter, have pretty much all of the spin. This completely baffled scientists for centuries. It's kind of like building a spinning top where the tiny little tip spins way faster than the huge body. It just doesn't make sense. So how do we solve this puzzle? Well, it all comes down to something called a great transfer. The theory is that the baby sun used its incredibly powerful magnetic fields like a set of brakes, dragging against the disk of gas and dust around it and slinging its spin, its angular momentum, outwards. In a way, the sun had to sacrifice its own spin so that the planets we live on could even exist. And you know what? That's not even the only weird thing about the sun's past. Our models of stars are really clear on this. When the sun was young, it was about 30% dimmer than it is now. Logically, that should have turned the early Earth into a giant snowball. And yet, we have solid geological proof of liquid oceans and even life from that exact same time period. How is that possible? The answer is Earth. Earth itself adapted. It basically had its own built-in thermostat. A geological feedback loop called the carbonate-silicate cycle pulled greenhouse gases out of the atmosphere or put them in, trapping more heat when the sun was cool and letting it go as the sun got brighter. The planet and its star were locked in this incredible co-evolutionary dance for billions of years. So you might think this elegant system we have today just happened. But no, it's not a story of gentle formation. This whole thing was forged in absolute chaos. The clean, stable orbits we see today, they're basically the scars left over from an unbelievably violent youth. First up, we think something called the Grand Tack happened. Jupiter literally plowed its way inward, almost to where Mars is now, before Saturn's gravity managed to yank it back out. Then, later, the giant planets all reshuffled their positions, flinging Uranus and Neptune way out and unleashing an absolute hailstorm of comets and asteroids onto the inner planets. We call that the late heavy bombardment. And this is where that Ouroboros idea comes roaring back. That incredibly destructive bombardment, the one that left all those craters on our moon,
was also, at the same time, an act of creation, because those very same comets and asteroids that were pummeling the early Earth, they were delivering the water and the organic molecules that would eventually make life possible. Destruction gave birth to creation.
Okay, so that was the violent past. What about today? Is everything just quiet now? Not at all. This system is still buzzing with activity, with these active cycles that are kind of like a planetary metabolism, constantly changing and reshaping entire worlds.
I mean, we all know Earth's metabolism, right? The water cycle. Water evaporates, it makes clouds, it rains, it flows through rivers back to the ocean. And that whole cycle is tied directly into that geological thermostat that's kept our planet livable for billions of years. Now get this, let's jump over to Saturn's moon Titan. It has almost the exact same kind of cycle, but with a totally different liquid, methane. It rains methane from the sky, which carves out rivers and fills up massive lakes. And the chemical byproducts of this whole process even build huge dunes out of solid, frozen hydrocarbons. It's a bizarre alien echo of Earth. And if you thought that was strange, wait till you hear about Pluto. On Pluto, there's a giant, heart-shaped glacier made of solid nitrogen ice. And this whole thing churns and flows in super slow motion, a process called solid-state convection. It basically acts like a cosmic lava lamp, constantly repaving Pluto's surface and erasing any craters that form. Now, I'm just going to give you a number, 54 gigawatts. That's how much heat energy is pouring out of Enceladus, Saturn's little tiny ice moon. For a world that small, that is a staggering amount of power. So, where is it all coming from? Well, the answer is tidal friction. Saturn's immense gravity is constantly squeezing and stretching the little moon. But here's the incredible part. The heat that's coming out, that 54 gigawatts, perfectly matches the energy that's going in from that tidal squeeze. And what that tells us is that Enceladus's hidden subsurface ocean is probably in a stable, long-term equilibrium, making it one of the absolute best places to go looking for life. All right, and this brings us to the final, most mind-bending loop of them all. After billions of years of just silent, mechanical, metabolic cycles, the system finally produced something completely new, an observer, us. The solar system, through us, is beginning to become aware of itself. You know, there's this thing astronauts talk about called the overview effect. When they see the Earth from space for the first time, they say it triggers this profound shift in how they think. The borders disappear, the conflicts seem tiny, and they see the planet for what it truly is, a single, fragile, deeply interconnected whole. They're seeing the Ouroboros with their own eyes. And look at what we're doing with our technology. We're basically building the system's own nervous system. The Voyager probes are like its sensory neurons, reaching out to finally touch its skin at the heliopause. The Parker Solar Probe is like a nerve ending, diving in to feel the heat of the system's heart in the sun's corona. And the ridiculously complex orbital models we build, that's the solar system through us, creating a cognitive map of itself. So when you put it all together, from the skin of the heliosphere to the sacrifice of the sun, from the chaos of its birth to the living cycles on alien worlds, you see this one grand looping story, a system that is constantly folding back in on itself. The final question then really is for us, as the part of the system that can actually think and observe and understand. What is our role in this cosmic serpent? What chapter are we writing right now?